I want you to imagine a closed trapdoor in the baseboards of a wooden floor. Imagine yourself flinging the door open. Now imagine throwing a deflated raft into the trapdoor, then inflating it until it's too large to be pulled back out through the door. Now close the door. This is what the chemical process of permanently dyeing your hair is like. A 2011 survey done by Dove found that 93% of women don't love their hair. The majority of these women have probably permanently dyed their hair in the hopes of finally loving how it looks. I would bet that most of them don't know about the chemical reactions that are taking place on their heads when they dye their hair, or why dyeing their hair is even possible in the first place. My name is Jessica Smith, and I've researched this topic extensively in preparation of this topic. Some of my resources include AmericanChemistrySociety.com, CompoundChem.com, which is a website run by a chemistry teacher, and LabMuffin.com, which is owned by a woman with a PhD in chemistry. Today, I would like to tell you about the process of changing human hair color with permanent hair dye in two different sections. First, we'll talk about the anatomy of human hair and why it is able to be dyed in the first place. And second, I'm going to give you information about the mixture of two specific chemicals, which is going to be ammonia and hydrogen peroxide, and the actual process that these chemicals go through to change human hair color. So I will begin by talking about the anatomy of human hair. You can refer to slide number 1 on my PowerPoint for a visual representation of what I'll be talking about. Every single strand of hair on our head has 3 different layers. The inside layer is called the medulla, as you can see on the visual. It's kind of like a hollow cylinder, and it actually is not involved in the hair dye process. So we're just going to ignore that layer. The middle layer, which is important in the chemical dye process, it's the cortex, and it's the structure that gives hair its appearance and shape, and it also contains the melanin pigment that produces your natural hair color. According to CompoundChem.com, these melanin pigments are the reason why our hair is able to be dyed in the first place. There are 2 kinds of melanin that can be found in hair. The first one is eumelanin, which causes darker shades of hair, and the other one is pheomelanin, which gives the color ranges between blonde and red. The outside layer, and the one that I'm describing in the trapdoor analogy, is the cuticle layer. This layer is made of dead cells that act as tiny overlapping trapdoors, if you can imagine that. When the trapdoors lay flat, the light bounces off your hair, and that's what makes your hair look shiny. We are able to open and close the tiny trapdoors, the tiny trapdoor cells in this layer with chemicals. So if our hair is the trapdoor in the analogy, then the chemicals mixed together are the physical act of you opening and closing the trapdoor, as well as placing the raft inside and inflating it. So there are 2 chemicals that are mixed together immediately before every permanent hair dye job. They're ammonia and hydrogen peroxide. According to the American Chemistry Society, ammonia causes the hair shaft to swell. So when the shaft swells, the cuticle cells, and remember that these are our tiny trapdoors, they open and separate because of the alkaline pH of the chemical. pH stands for potential of hydrogen, and it's based on a scale ranging from 0 to 14. So completely acidic is on the 0 end of the scale, and completely basic or alkaline is on the complete other side, or the 14 side of the scale. So when you hear me say alkaline pH, it basically means that it's not acidic. The ammonia comes pre-mixed with couplers. These couplers are what modify and change the exact hair color. The couplers, they actually are not activated until they're oxidized. So this brings us to our next chemical, hydrogen peroxide, which I think plays an equal, if not more important role in this process than ammonia. So after our trapdoor is opened, with the help of our ammonia, peroxide is able to reach the cortex of the hair. And remember, I said earlier, this is where our actual hair color is. You can think of this step in our analogy as you throwing the deflated raft into the open trapdoor. So the hydrogen peroxide breaks down the melanin in the cortex of the hair, which leaves it colorless. It also simultaneously works as the oxidizer we need to allow the couplers in the ammonia to work their magic and start coloring the hair. Because now it's colorless, so now they can do their job and color it. There are a few ways in which substances in general can be oxidized, but in this context, oxidizing means gaining oxygen. This oxidizing process causes the inflation of the raft in our analogy. So this will be the molecules connecting, and they increase in size to the point where they're too big to get past our trapdoor. Or remember, trapdoor is the cuticle layer of the hair. So this is what makes permanent hair dye permanent. The colored molecules are just too big to fit back out through the cuticle layer after our trapdoors are closed by using conditioner. So after a hair dye, you'll get a deep condition, and that's what closes the doors. And you can look at slide number 2 on my PowerPoint to see the big picture of all of this happening. In this speech, I have taught you the process of changing human hair color with permanent hair dye using hydrogen peroxide and ammonia. Remember, these chemicals work together by utilizing the anatomy of human hair. So next time you decide to permanently change your hair color, I hope you can imagine all the tiny trapdoors being opened and closed and rafts being inflated on the top of your head.